This is section 20.2 in Klein's organic chemistry textbook, and we want to talk about the nomenclature of aldehydes and ketones. So let's first tackle aldehydes. Okay. Now, aldehydes and ketones are named very similar to alcohols. Okay. So first, you want to identify the parent chain. And the idea here is that the parent chain needs to contain the carbonyl. That's that thing that's bonded to an oxygen atom as a pi bond, okay? So this right here is called the carbonyl carbon, okay? So the parent chain must contain that carbon. Doesn't matter how long the side groups are, okay? And as usual, you want to identify and name the substituents. We've talked about quite a few substituents besides just the methyl and the ethyl. We know halogens, we know oxygen might be a hydroxyl group, or it might be a methoxy or ethoxy as in an ether, okay? You want to assign the location, so basically get the numbering of everything, and then you want to alphabetize things, okay? So let's just look at some simple cases here. So if you have something like this, okay, so again, we're just talking about aldehydes for now. So this is the longest chain here, 4, 5, 6. This is just called hexane. The parent chain is 6 carbons long. Okay, and this is hexane as well, but we changed the name by adding an AL to it, okay? So we changed the name hexane. Okay, so we drop the E there and we add AL, okay? You can kind of think of this as a nickname for Albert, right? Albert might have a nickname Al. So we could call it hexanaldehyde, but Al is short for, or a nickname for the aldehyde, okay? So we call it hexanal. Now we never need a number for aldehydes because aldehydes are always going to be at carbon 1, okay? Okay, and that's the important thing to remember. So let's get more into this. If you have some kind of substance like this, okay, the longest chain here is found by counting the carbons in every single branch that you can think of. And we can see here that the longest chain is just going to be here from left to right. That's octane, right? So octane would be the parent chain here. If we have a molecule that looks like this, okay, so octane this is the longest continuous chain of carbon atoms. But remember that when you identify the parent chain for aldehydes, it needs to include this carbon. So we can go to the left or we can go to the right. So that's going to be carbon 1, right? So this would be 2, 3, 4, 5 working to the left, or 2, 3, 4, 5, 6 working to the right. So the parent chain here is going to be hexane, so this is a hexanal as well, okay? All right, so once you have the functional group, you need to remember that your longest chain or your parent chain has to include that priority functional group, okay? Now, the important thing here that we need to remember is that aldehydes have a higher priority than alcohols or alkenes, for example, okay? So if we have a molecule that looks like this, I don't know, I'm just making up something here. You might start numbering like this to place the alkene at carbon 1, the hydroxyl group at carbon 3. Those have lower numberings, right? But the actual real best way to do this is this way, okay? It seems wrong because you're placing the alkene at a carbon 4, you're placing the hydroxyl group at carbon 3, but that is necessary because the aldehyde has the highest priority and the aldehyde is always carbon 1, okay? Okay, so the name of this would be, 3-hydroxy pent-2-ene pentanal. Okay, so this is complicated. We won't try to name this here, but I just want to make sure that we're numbering things correctly. The last thing I want to talk about is the carbaldehyde group. Okay, if you have something like this, this would be cyclopentane carbaldehyde. Okay, so this right here is a carbaldehyde group. Okay, so if you have weird stuff that you're not quite sure how to name it because it's not part of the longest chain, right? There's 5 carbons in that ring and that aldehyde is off the side of the ring. So it's sometimes easier to name it as a substituent. Now, if you have stereochemistry, okay, like this, I don't know if this is R or S. I don't want to really think about this. The stereochemistry is going to be named at the beginning of the name. Okay, so S, blah, 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 blah. Okay, so as usual, stereochemistry is indicated at the beginning of the name. It could be 2S or it could be S-2 and so on. Okay, so that in a nutshell is how to name aldehydes. Okay. Now, there are a few names that you need to memorize, and we've talked about them in the previous video, some of them. First, you've got formaldehyde, okay, and the IUPAC recognizes these common names as acceptable. So this right here is formaldehyde. Okay, it's used as a disinfectant or a preservative in biology, for example. We've got acetaldehyde. This is formed when alcohol gets metabolized by humans and acetaldehyde builds up and gives that hangover feeling and headaches and nausea and sickness in general, okay? So that's acetaldehyde. And we've talked about benzaldehyde in chapter 19, I believe it was. These 3 aldehydes will show up quite a bit and they should be memorized, okay? All right. We'll do a practice problem later, but now let me talk about how to name ketones. Now, ketones can be at carbons 2 or 3 or something like that. Okay, it's possible, but never at carbon 1. If an aldehyde is at carbon 1, if a ketone is at carbon 1, it's going to be an aldehyde, so it has to be at carbons 2 or whatever. It can't be at the very ends of the chain. So if we have a molecule that looks like this, we call that pentane again because that's the longest chain and it's very simple, right? And if we have something like this, okay, we number the chain, okay? And we have a number here, okay? So this is going to be a pentanone, okay? So you drop the E from pentane and you add one, okay? So it's going to be pentanone. Okay, so here's pentan, and then you're going to add O-N-E. So ketones end in O-N-E as the ending, and aldehydes end in A-L, all right? So the name of this would be 3-pentanone. And that was generally how people named things prior to the 1990s or so. Now, the newer way of naming things is pentan 3-one, okay? And I believe any organic chemistry professor teaching you would accept either of these names as acceptable, okay? So, yeah, it says in the book here that it was changed in 1993, and then in 2004 they allow they allowed this new naming convention. Okay, so depends on how old your professor was when they received their education, or how they teach. Okay, so rules always change. So either of these is fine in my class. All right. So what common ketones do you need to memorize? We've got acetone. Acetone is commonly known as acetone, of course, but we could also name it 2-propanone. Okay. Acetophenone we learned in chapter 19. Looks like that. It's an aromatic molecule. And benzophenone is an interesting molecule where you have 2 phenyl rings flanking the carbonyl. Okay. So it depends on what labs you're doing, but you might actually use that in a photochemical reaction. Okay. Now some people are kind of lazy with naming things, and if you have something like this is a very old way and I don't recommend it, but this right here is an ethyl group. This is a propyl group. Okay, and then we want to alphabetize things, so this would be ethyl propyl ketone. Now you can go to the hardware store and pick up some paint thinner or solvent. It's called Meek, and it's alphabetized wrong, and it's spelled in a weird way, and it uses the old naming convention. But this stands for methyl, ethyl, ketone. Okay, and there's an extra E in there just so it sounds like a word or something. So here's methyl, ethyl, ketone. So we'll add the E for the methyl. So this is not alphabetized correctly because we know ethyl should come before methyl, but let's just draw the structure. So here's a methyl group. Okay, I'll draw it out here. And then here's an ethyl group. Okay, so this is a great solvent for, cleaning up things in a degreaser and stuff like that. It's similar to acetone, but it has a slightly higher boiling point, so it doesn't evaporate as readily. Okay? All right, now that we've been through the basics of how to name things and look through the rules, I would like to now work on problem 1 in chapter 20. Okay, this is problem 1 in chapter 20, and the problem says just assign a systematic IUPAC name to each of the following compounds. In problem A, we have an aldehyde. This is easy. We know the aldehyde should be carbon 1. Okay, so this is a hexanal, and we don't need to say 1 hexanal. There are 2 methyl groups at carbon 2, and there's 2 bromo groups at carbon 5. So B before M, so it's going to be 5, 5. Okay, dibromo. Remember, we put a dash between any number and letter. So this is 5, 5 dibromo, and then we want to say 2, 2 dimethyl. Okay, and the parent chain is hexanal. So that's it. And it ends in AL. I'll just highlight that in maybe yellow here since. Now don't write OL because OL is an alcohol, all right? So that's slightly different. In molecule B here, we have a ketone. We want to number it so that the ketone has a lower numbering system. okay? So there's a methyl at carbon 3, there's a methyl at carbon 4, and there's a methyl at carbon 5. So if you have 3 methyl groups, that's called trimethyl, okay? Trimethyl. Now we have a stereochemistry at carbon 3 and a stereochemistry at carbon 4. So this is going to be 3R or S. I haven't figured this out yet, okay? It's going to be, and then there's 2 stereogenic centers, so we'll put a comma, and this is going to be 4R or S. Not sure which one yet, okay? And then I'll name this. So it's 3,4,5 trimethyl. Okay, and once again, this is a 6-carbon parent chain, but we've got the ketone at group. So I'm going to name it with the newer 2004 modern edition, hexane dash or hexane dash 2-one. Okay, hexane 2-one. Okay. Now we need to figure out the stereochemistry here. So let's go ahead and show the lightest substituent here, which is carbon 4. This carbon is going to be priority 1. This carbon is going to be priority 2. This carbon is going to be priority 3. 1, 2, 3 looks counterclockwise, but the lightest substituent is the wrong way, so it should be clockwise. Okay, so that should be 3R. Okay, so I'll just fix that here with the naming. Carbon 4, let's erase these scribbles here. Okay, we have the lightest substituent here, which is carbon 4, and then we have priority 1 is going to be this whole chain here because of the oxygen that breaks the tie. Priority 2 is here. Priority 3 is the methyl group. So 1, 2, 3, it looks like it's R, but the lightest substituent is going the wrong way. It's coming towards us, not behind, so that's S. So it's 4S. So let's fix the name here. Oops, sorry about that. That's going to be 4S. Okay, so 3R, 4S, as good as I can do it really quick here. 3,4,5 trimethyl hexane dash 2-one. Okay, double check the stereochemistry on your own very carefully. It's hard for me to speak and do things at the same time sometimes. Now, molecule C is the cyclic system is the longest chain. So there's 5 carbons in a ring there. So that's going to be a cyclopentanone. Okay, and we have 4 methyl groups. Now let's number things here carefully. Now remember that if you have a ketone in a ring, we want to position that at the highest priority, carbon 1. Okay, and since it's a ring, we don't need to say carbon 1. For example, if you have something like this, if I told you, hey, I have a structure called cyclopentanone, you would not be confused that there's a ketone there. So I don't need to say 1 cyclopentanone. So I don't need to say 1 cyclopentanone here either because it's a ring, it's a cyclosystem, okay? So the name of this is going to be 2,2,5,5 tetramethyl, okay? And you just need to say cyclopentanone here on the end. Okay? If you're taking notes as you're watching this video, you just might make a note that when you have a cyclic system, your ketone is always at number 1. Okay, it's at carbon 1. In molecule D here, remember that we have an aldehyde. That has to be carbon 1. And then we could number to the left or to the right. And either way, it's good. Okay? So that's 5 carbons as the longest chain. And this right here is a propyl group attached to carbon 2. So this is going to be 2-propyl pentanal. Okay. Well, looks kind of weird when I do it like that, but it's pentane, which is the parent chain. And remember, the ending ends in AL, okay? Okay, so I just want to highlight that that's the ending there. Okay, I might do it up here as well. This is a ketone, okay? So in molecule E, let's see what's going on here. Okay, so this is a situation where you have 4 carbons in a ring. That kind of seems like the parent chain. And then you have this aldehyde that's hanging off of that. So this is going to be called a carbaldehyde. So this is cyclobutane, carbaldehyde. I wish we would just name it Carbal or something, but they don't. And so once again, you might make a note to yourself that when you have a cyclo ring, you don't need to use a 1 when you have one substituent attached. So let's name some diketones or something here. So let's see, we've got problem 20.4. Okay, 20.4. There's a little bit of introduction in that problem, and then they ask you to name some things. So it's a really wordy problem. So let me just do that now for you. As I stated, this is a very wordy problem. There's like a whole paragraph of stuff, and then they say, okay, this is how you name it when you have 2 or 3 ketones, and let's name these. Okay, so we want to number our, that doesn't show up very well on the screen. Let's try a different color. We want to number the chain here. Okay. Always positioning the ketone at carbon 1 is the best way. So there's a ketone at 1 and a ketone at 3. So we're going to name this 1,3. Okay. Cyclohexane. Okay. And then we're going to tap on dione. Okay. Dione. And where are those 2 ketones? They're at carbons 1 and 3. Let's do this one. This is going to have a similar name, but the 2 ketones are at carbons 1 and 4. Okay, so if you have 2, they're at those 2 numbers. Here, you want a number from right to left and left to right and figure out which is better. This molecule is perfectly symmetric down the center of the page, so it doesn't matter. I'm going to number it from left to right as I'm doing now. So I've got a ketone at carbons 2, 5, and 8. So if there's 3, it's going to be tri. Okay, so this is going to be, what is it? Nonane. Okay, so this is going to be nonane. And then it's going to be trione. Okay, if it looks weird, that's fine. You're seeing it probably for the first time. I believe that's where I wanted to end this. Oh, I did want to say that in the textbook, which I think is excellent, they always have these things below problems like, oh, do you need more practice? Try problems 20.44 all the way through 20.49. I urge you to self-study those problems to gain more confidence and skill naming aldehydes and ketones. Thanks for watching.